Let's look at this average rate of change. So an average rate of change takes 2 points on any function. So here we've got f of x, and we've got points a comma f of a. So f of a is what we get when we plug a into our function, and we have b comma f of b. F of b is what we get when we plug b into our function. The secant line is the line that connects those 2 points and that cuts the function f, because secant comes from the Latin word secare, meaning to cut or to sever. The slope of a line is always y2 minus y1 y2 minus y1 divided by x2 minus x1, where we have 2 points, x1, y1, and x2, y2. Well, we're using b for x2. So let's see. Okay, wait. All right, we've got slope equals. We're using b for x2. Put that in here. We're using a for x1. So we're using f of a for y1. So let's see, f of a, then a minus, and we're using f of b for y2. And that gives us the slope of this line that joins 2 points. Those points happen to be on this curve, f of x. Well, groovy. So that's all of this bit. We're calling this the average rate of change. So rate of change is how much a function is changing. Here, we're not getting an actual rate of change, but we're getting close to one. We're finding how much this function is changing when we look at the 2 points, a f of a and b f of b. Eventually, we're going to let a and b point b f of b get very close to a f of a, but not today. Let's just remember that the equation of any straight line in slope-intercept form is y equals mx plus b, where m is the slope and 0 comma b is the y-intercept. Remember, b is a number. A y-intercept is a point. 0 comma b is the y-intercept. B is the number that y has to take on, but x is 0. So we have to have both of those. Okay, so now we're ready to look at our procedures and proceed. To find the average rate of change, an average rate of change, let's just keep remembering, that is a slope. For any function f, we first find f of a and f of b for the values in this interval. So this notation, a comma b, those are both x values. We're saying a is at the beginning of our interval, b is the value of x at the end of the interval, and each of these values have associated function values. Okay, sweet. So to find the average rate of change on the interval AB for the function f, we're going to find f of b minus f of a in the numerator. That's y2 minus y1. And in the denominator, b minus a. That's x2 minus x1. So this is a slope. And that's the first thing we're going to do. And then the steps for finding the equation of the secant line, the equation of this line. So here's the line. We want to find its equation. And we're going to use slope-intercept form, which is y equals mx plus b, where m is the slope and 0 comma b is the y-intercept. We're going to use x and y from one of our points. And in these directions, I'm using a comma f of a. I could also use b comma f of b. I'm going to let x equal a, y equal f of a, and m is going to be the value we just found, the average rate of change on that interval a comma b, the slope of that line. So we're going to write down y equals mx plus b, fill in y as f of a, x as a, m is the average rate of change on the interval AB, and we're going to solve for b. Groovy. Let's do all that stuff for this first function. So we have, this is example 1. F of x is equal to negative 2x plus 1. Before we do anything, let's remember what we already know about this kind of function. And let's sketch the graph. We know that since the exponent on x is 1, this is a linear function. So it's a function that looks like a line. The number in front of x, the coefficient of x, is negative 2. The coefficient of x in a linear function is the slope. And b, so it looks like b is equal to 1, so the y-intercept is 0 comma 1. So let's plot 0 comma 1. Zero comma 1, and a slope of negative 2. Oh, I remember something about slopes. Slopes are rise or fall over run. Well, to write this as a fraction, but we're out of focus. Trying to get it to focus. My hand will focus, but I wonder if I make it closer. I'm not really sure why it's not focusing. Um, it was focusing, wasn't it? I'm going to pause the video and see if I can fix this. All right. So we have a slope of -2, but that doesn't tell me rise or fall over run. So I'm going to write -2 over 1, because we can write any integer divided by 1. And now I can see I've got a fall, because it's negative, of 2, and I have a run of 1. So starting at our point 0, 1, let's do a fall of 2 and a run of 1. And join those two lines up. We join these 2 points. So there's our linear function. F of x is equal to -2x plus 1. Okay, now we can begin our question. It says that we want to find the average rate of change on the interval -1 to 3. And then we want to find the equation of that line. Okay, so we want little a to be -1. And we want b to be 3. So we need to find f of a. Well, that's just taking our function, -2 times x plus 1, but we're putting the number -1 in for x, and -1 times -2 is +2, plus 1 is 3. So f of -1 is 3. I apologize for the focus. I'm not really sure why it's not focusing well. For b, f of b, again, is just -2 times b plus 1. This time, the number that we're plugging in is 3. So we get -6 plus 1, which is -5. So our point here at 3, comma, -5. So we have, let's see, this is b, f of b, and the point in the light blue is a, f of a. Groovy. So we need to find the slope of the line that joins these 2 points. I'm going to move this down. I know that slope is equal, and you're going to use this form so often that I want to go ahead and get used to it. Slope is equal to f of b minus f of a over b minus a. Where our 2 points, a f of a is negative 1, 3, and b f of b is 3, negative 5. So those are our 2 points. We're going to find the slope. That slope is the average rate of change of our function f on the interval from x equals a, which is negative 1 for us in this question, up to x equals b. All right, so we've got the average rate of change on the interval from negative 1 to 3. We said the f of b was negative 5, and that b was 3. We said the f of a was 3, and that a was negative 1. Well, this is fun. We like fractions. Absolutely. Negative 5 minus 3. Remember, if the two numbers have the same sign, add the numbers. 5 plus 3 is 8, and give them the common sign. So here we'll have negative 8. And in the denominator, we have 3 minus negative 1. So that's 3 plus 1, which is 4. And negative 8 divided by 4 is negative 2. Well, this is interesting. The slope of the average rate of change is the same as the slope of the original function. And remember, average rate of change is talking about a slope or an average associated with a function. So we got the average rate of change between negative 1 and 3 is negative 2. Let's find the equation of the line that joins f of a f of a and b f of b. Again, we said that a f of a was negative 1 comma 3. B f of b was 3 comma negative 5. And we just found the slope. So m, which is the average rate of change between the x value negative 1 and the x value 3, we said that was negative 2. We're going to use the slope-intercept form of a line. And that is y equals mx plus b. Here we have an x value, a y value, and a slope. So we're going to use x equal negative 1. Oh, actually, that's not very much fun. Let's use the values of b this time, only because I don't want this pattern, negative 1 to 3, to look like this interval. So let's let x be 3, y be -5 and m be -2, just like we found. And let's solve for b. So we've got y equals mx plus b equals plus b. All right. We said that y was -5, x was 3, and the slope is -2. That's not so bad. Now let's see what we've got. -5 is equal to -2 times 3 is -6 plus b. And now we can solve for b. We can add 6 to both sides. And we get that 1 is equal to b, so that the y-intercept is 0b. Remember, 0b. Y-intercept is a point. So the equation of the line that joins those 2 points, it contains the point 0, 1, and the slope is equal to -2. So now we just write y equals x plus. So we found the slope was -2, and that's it. This y-intercept. There we go. So the equation of the line of the tangent, of the secant line, secant means to cut or sever. So the equation of the secant line joining -1, 3, and 3, -5 is y equals -2x plus 1. And check this out. That is exactly the function we started with. F of x equals -2x plus 1. So the function and the secant line are the same line. And that's because as x changes, the slope of a straight line stays the same. The slope up here is -2. If we measured it here, we'd get -2. If we measured it here, we'd get -2. The slope is always -2. For a straight line, it doesn't change.